So algorithm, what is algorithm, folks? When you describe somebody's behavior with the formal words, that is algorithm. For example, you would like to do something like wake up in the morning, brush your teeth, and drink the coffee. You have a special rules for this. When you hear the alarm clock, you watch the alarm clock and then you see it's 4:30 a.m. If it's 4:30, it's not time to wake up. This is time to continue sleep. But it's 7:30, then you need to wake up. Then when you wake up, then next you go to bathroom, find your own toothbrush, and pick up the toothpaste and brush your teeth. Brush your teeth during 1 minute, for example. Is 1 minute over? Then you finish brushing. And so this is description of what you do in the computer. This is a program. Algorithm works as a program for the computer because computer is a smart device. It can do a lot of things, but it's never know what to do. So computer must commit instructions, and instructions is a sequence of directions of what to do. Sequence. Like number one, number two, number three, number four, and so on. Like I told you, for example, what you do in the morning. So any human action could be described as algorithm. For example, you need to go to get a bread loaf, right? So this is sequence of operation. You look for the keys, you look for the money, then you open your door from inside. You turn around, you close your door, you look the direction to elevator, you step out of the apartment to the elevator. You find elevator. You push the button on elevator. Is the button feels that you pushed it, so it gives you a light. If the light is not lighting, so then you need to go to find stairwell and go down, and so on and so on and so on. So this is algorithm. If you would like to know actually what is this in the formal description, so the algorithm is explicit description of somebody's behavior. In algorithm, we have two different models. One model of algorithm is action. So I can say the action. This is just something doing something. For example, you make a sip of water from the cup, or you made a step towards the outside the door of your apartment. Nothing, no more questions about it. So you have to do this action if the action described in the inside of the model. Next model is conditional model. Conditional. Conditional. Conditional model, folks, is a logical model. Logical model actually ask about situation that described by it. Situation could be either true or false. For example, if I have a car, right? I could have a car, I couldn't have a car. So if you really need to know, do I have a car? You ask me question, do you have a car? Or even in different form. Is that true that you have a car? And answer of the conditional operations could be two different answers. One answer is yes, another answer is no. And also yes is true and no is false. Okay, now how algorithm looks like. Let me take some kind of action and I will explain what action it will be. Consider that you have a bottle of liquid. I don't know what inside, maybe wine, maybe gasoline, maybe whatever. But you need to cork the bottle. So, and you have a bag of corks. Some corks are much bigger than throat of the bottle. Some corks are thinner than this. So you need to find out which one is appropriate. And I will start algorithm right here. So to start algorithm, you need to make the model, the small model, and write down start. Because without starting, when you initiate algorithm, it will start. Next, folks, next is arrow. Arrow is connecting the first module to the next module. Next module fix, folks, will be to pick the cork. I will put here take the cork. Take the cork from the bag or from the box, I don't know what. Take a cork. And then next action will be try cork. Now, the result of trying could be different, right? The cork either will be bigger or not bigger. So let's try to figure out the conditional model. Here, I'll put conditional model. False conditional model looks like a rhomboid, like this. In this conditional model, I will ask, is cork bigger than throat, than bottle? So folks, if no, I will put here no. If yes, I'll put here yes. You see, this operation has two arrows outside of this, going out from this module. But if cork is bigger, no, meaning cork is not bigger. But cork could be smaller. So then I will make a next model. Next model will be like this. Is cork smaller? In both cases, if it's not bigger, it could be smaller. But if it's smaller and smaller, I will say yes, it is smaller. We cannot use it because it will just go inside of the bottle. So only if it's not bigger and not smaller, all right, the cork will be good for the bottle, and then next action will be what? Cork the bottle. Cork the bottle and then stop. But we have two hanging exits here, yes and yes. As soon as we say that algorithm is explicit description of behavior, so we need to connect this somewhere. But let's discuss it. So if the cork is bigger and yes, we need to take another cork, right? We need to throw this cork out and go to take a cork. That's meaning take a fresh cork. But if the cork is smaller, we need to go to the same place. We need to take another cork and try another cork. So you can see this completed now. Folks, how it works, let me explain. Start. Take a cork. Try a cork. This is understandable, right? But then, cork could be bigger. Is the cork bigger? No. Is the cork smaller? I forgot to put here no. If it's not bigger, not smaller, then it's appropriate, right? Cork the bottle and stop. But if the cork is bigger, so it's not getting into the throat of the bottle, so I will go here and yes, I need to take another cork. But is the cork not bigger, but it could be smaller? If yes, I need to take another cork. You understand, right, folks? So that is the cycles, that is linear part, and this algorithm will work. But this is kind of dangerous in this algorithm. Let me tell you what danger is. Consider that there is no appropriate cork in the bag. All corks are bigger or some corks are smaller, but not one of the cork is appropriate size. In this case, we will go here to be in cycle forever. You understand why, right? Do you?
Yes.
Okay, very good. So, how to modify this algorithm in a manner that we will take, let's say, 20 corks, not more, and if there is no appropriate cork with the size of the bottle, we must stop this algorithm. If within this number of corks, let's say 20 corks, we will find appropriate one, that's good. If we don't find, we just stop trying. So I will go to make another algorithm, folks. Another algorithm right here. So that will be a start. Start, can you see this now? And here we'll go to the same two actions. Same two actions that will be take a cork and try a cork. Then it could be the same result. But how can we measure quantity of 20 corks? 20 corks. We need to create a counter. Folks, what is a counter? Let me explain. Counter. Counter is, let's say, a little cell where in the beginning I'll put 0. But in every time I pass through the cell, I will plus 1. And that will be first pass will be 1, second pass will be 2, third pass will be 3, and so on. But in the beginning, I need to put here additional matter. Put 0 to the counter. So this is counter. Again, what is a counter in the computer? In the computer, it's just a cell of memory where information must be memorized. So I can actually clean it up. That will be 0 here, and that you will find out that 0 is in the counter of memory. Then I will say counter here, counter is equal n. N is a number of quarks I analyzed. Then I will go for the same modules that you can see here. So I will go for the model. Is quark bigger? No. Here will be yes. Next operation will be is quark smaller? Yes, no. Okay, so if no, no, meaning the cork is appropriate, in this case, I will cork the bottle, and stop. Cork the bottle and stop. But what's happened if yes? If yes, folks, we need to do a certain thing. Because we already took the cork, so we need to create a module like this. 1 plus n. Can you see? 1 plus n. That's meaning I will add 1 to the counter. And then I need to check after this. Is n equal 20? Folks, remember I told you that I need to count 20 corks. If 20 corks are not good, so I will just drop this business. And here will be no. If no, I will go right here and take a cork. But if yes, I will go to stop. Okay, this is a little bit more complicated, right? Now I need to explain how it works. Be attentive now. Take a look, folks. The idea is it's a bag of corks, and I need to pick up the cork and try it on the bottle. If cork is appropriate, I will just go and stop. But if cork is bigger, I will try another cork. If cork is smaller, I will try another cork. But number of corks I try not exceeded 20. 20 corks. So to count 20 corks, I establish counter, and counter is equal n. So take a look. Here I reset the counter. This is 0 sent to counter. And you can see this arrow, that meaning send. 0 sent to counter. Then take a cork, try a cork. Is the cork bigger? If the cork bigger, it's not good. So I will go for 1 plus n. 1 plus n, this is counter. N after this will be 1. Is n equal 20? No. For no, I will go to take another. Let's go again. Take a cork, try a cork. Is cork bigger? No. Is cork smaller? If yes, I will add additional 1 to n. N will be equal to. Is n equal 20? No. I will go take another cork. If yes, I need to stop algorithm. Any questions about this, folks?
Yes,
It's
Professor.
clear, right?
Yeah,
Huh?
yes, Professor. In the first years, of the
Okay,
course,
what is the problem with the second one?
yeah,
What is understandable?
no, let me understand the first one before the second one. The first one says, is that 1 plus n or cork plus n? This one. Okay. Yeah.
This one,
Yeah.
1 plus n. 1
1.
plus n, take a look. First, when we started, n was 0, right?
Yeah.
But when you go through this module, you add 1 plus n. N will be equal 1 after that, right?
Okay.
And then you check n. Is n equal 20? No, so take another cork. You go try another cork. The cork is bigger. Yes. N was 1, right?
Yes.
But now it will be 2. Consider.
Okay.
Because you pass through this model again. And again, that will be 2 because you add 1 to n. Can you see?
Okay.
So it will be 2. Is n 20? It's not 20. Let's go no. So you go to take another cork. Try another cork. The cork is not bigger, but cork is smaller. Yes, you go to this module again. 1 plus n. N will be now what? 3, right?
3. Okay.
3. Is it n 20? No.
No.
And then we'll go to take another cork. So if you're unsuccessful with cork, n will be accumulated, and then will be 3, 4, 5. How many tries you made, so many it will be in n. And then eventually n will be 20. If n 20, you said, I'm tired, I cannot find cork for this bottle. 20 is enough. And then you will go to stop, right? Can you see?
Yeah. So 20 is the maximum in this case.
20 is, yes, absolutely correct. 20 is the maximum. If somebody tell you, are you lazy? You need to find out 100 corks. If through 100 corks, at least one. In this case, what you need to do, you need to change 20 to 100, right?
Okay.
And then you will make 100 tries.
So in this case, we continue to add one until the cock says yes.
You will go through this branch,
Yeah.
add one. First it will be 1. Second time you go here will be 2. Second time it will be 3. Third time it will be 4. Fourth time it will be 4, and so on and so on. And eventually, 20th time it will be 20. And when it's 20, you'll go down and go to stop.
Okay. Last
So
question. Suppose if we get to the last number, which is 20, and it is still no, what do we do?
how it could be? It's ask you, is n 20? You cannot
Okay.
go to no, right?
Okay.
It will
Okay.
not be true.
Okay. No.
I
I'm
said,
trying to
is it
understand.
20? Is n 20? I said 20 and said no. How
Okay.
20 will be not 20, right?
Okay, Professor. So before
You
we exhaust
understand, right?
before we exhaust the 20, definitely we must get it correct. All right.
When n is 20, you cannot go for no,
Okay.
because that will be lie. True is when n is 20, you go for yes. Computer cannot lie. Computer doing everything truthfully.
Okay.
All right?
Thank you. Thank you,
Okay,
Professor.
so this algorithm is understandable. Folks, the difference is this can run forever if there is no appropriate corks. But this one will run 20 times, and then if no corks, that will be go out. Now you folks need to understand that algorithm must consider all exits, yes and no. And now let me tell you folks, assignment. This is assignment for algorithm that you must do. What kind of? Consider that you're doing something, I don't know what, feeding baby, right? Or give baby a bath, or preparing coffee for the morning, or drinking coffee. For example, algorithm of drinking coffee. Let me do this algorithm for you. Definitely I need to go for start. Consider the coffee already in a cup, and coffee is ready to drink. Then first make one sip. So you're doing one swallow, right? Swallow. Then is the cup empty? Yes. Stop. No. Can you see the algorithm of drinking coffee? Look, start, make one sip, swallow. Is the cup empty? If no, make one sip, swallow. Is the cup empty? No. So you make sip by sip, and eventually, is the cup empty? Yes. Stop. Folks, any questions about algorithms? Feel free to ask me, guys. Because your assignment will be create your own algorithm. You can ask me about what? About anything you're doing. Okay? You can make your hairdress, or you can go to make your sandwich, or you can go to drink your tea or coffee, or whatever you're doing. I need to have this algorithm in a graphical form, right? In a form of module diagrams, in a block diagram. And either you will attach this picture to the email and send to me, or I will make a place where you attach it to the test area. The due date is 2 weeks for this. Oh, okay, 3 weeks. I will be generous. 3 weeks for algorithm. But it's very important. Now, folks, let me give you a couple of other samples of the algorithm, couple of other samples, so you will be able to understand it better. Consider that you have a room, and you need to know the size of your room in steps. Size of your room in steps. How to measure? You need to imagine, all right? You will go to the wall and start from the wall to make a step. consider the room is empty, nothing in the room. So you need to just make a first step and create a counter and make counter equal 1. Then make another step, counter will be 2. Make another step, counter will be 3. So this way you can make a measurement of your room in steps. Let me do this for you guys so you will see this. Again, algorithm will go from the word start. Then the first thing, again, the counter will be, let's say, variable, and that will be n. And I will get the 0, and I will send this 0 to the counter n. Then I will go for make another arrow, and we'll make another command module, and that will be module make a step. Folks, if you made a step, you need to add this step to the counter. So I will go for this. Look how I will put to add 1 to counter. I will put 1 plus n and send back to n. This record meaning I will take the cell where n is plus 1 and send it back to n. Record it back to this cell. So this cell is memory. This is memory of the counting, right? So here, 1 plus n, send back to n. And then I will ask the conditional question. So that will be my rhomboid. Is the wall here? What does that mean, folks? So step by step, you eventually go and feel the wall in front of you. Is the wall here? So if no, you need to make a step again. So that will be no, and that will be make a step. If yes, then I need to know the amount of n. So I will go for print n, and then stop. Now look at this, folks. Do you understand how it works, or I need explain additionally? Come on, folks, interact with me.
Can I say something?
Yes, absolutely.
Yes. When we are making the wall, the first wall after 1 plus n, when we're making the wall here, we got the first one by our right is no. So
no, and then you go to make another step. Yes.
We go to make another step. And after that, the first wall, which was no.
No. Take a look. After you made another step, the second step, you'll go to the module, add 1 to n. But n already was, from the first time, it was 1, right? So now it will be 2.
2. Yeah.
So you made 2 steps and you count by 2. Then is the wall here? The wall still not here because what is the room for 2 steps? It's too small. Okay, so it will go for no. You made another step. Make a step. You made third step and you add 1 to the counter. So that counter will be 3. And then you'll go to, is the wall here? So you will make, let's say, 20 steps, and then eventually the wall will be in front of you. And then the wall here, and then you'll say print n. So if you made 25 steps before the wall coming right in front of your face, that will be 20, n will be 20, and you'll print n, and then you will see how big is the room in steps.
Okay.
Clear, right?
Yes.
All right, but folks, with this algorithm, I have one problem. Consider the room is too big. Let's say somebody just put you on a street and said, can you measure this room, please? And you start measuring. Take a look. 0 to counter, make 1 step. Let me take the pointing. Make 1 step, 1 to n. That n is 1. Is the wall here? No. You make another one, n is 2. Is the wall here? No. Then you make 100 steps. Is the wall here? Because you're on a street, the wall is not here. It's a highway, right? It's not an apartment. Then you made 1,000 steps and the wall's still not there. And then you make 10,000 steps and the wall's still not there, so you will die here. This algorithm will make you tired and will bring you to the death because you cannot go through the entire planet Earth. So we need to modify this. Actually, if this is apartment, let's say the number of steps could be less than 100, I believe, right? Do you understand me, guys? Hello?
Yes.
You understood. All right, so I will modify this algorithm to make another algorithm, which will make limitation for the number of steps. Let me do this. Okay, I will make this start. You can see it, right? Can you?
Yeah, we can see it, Professor.
0 sent to n. So I will send 0 to n to the counter. Then, as usual, I will make two operations like this. Two operations. Make step and 1 plus n and send back to n. Increase n by 1. Then I will make this question. Is n equal 100? I'll put the limitation. If you would like to make super huge apartment, right? You can make this 1000. But I consider 100 steps is good for one room. And that exit is no. And then I will ask another question. Another question will be, is the wall here? And if the wall here, yes, then that will be print n and stop. But we have here yes and no. Folks, if n is 100 already, then I have to go to stop because the room is too big for me to measure it. But if no, I need to go to make another step. It's right here. Now look how this works. Start, reset counter, make a step, add 1 to the counter. Counter is equal 1. Is n equal 100? Definitely no, because we just made one step. Is the wall here? No, the wall is not here. So for this no, I will go to make another step. Make a step. That will be second step. 1 plus n, that n will be 2. Is n is 100? No. So is the wall here? No. I will go to make the third step. Make a step, add 1 to n will be 3. And then that will be, is n is equal 100? No. And then is the wall here? If yes, print n and stop. So let's say my small room has 3 steps, or could be 13, or whatever. But if I make step by step, right here, step by step, and eventually I made 100 steps, okay, and didn't find the wall. So yes, I will just stop here. I can print there is no wall, or the room is too big. I will print here, print room too big. Do you understand me, guys? Hello?
Yes, Professor.
Yes, it's understandable. All right. So, folks, this is what I would like to tell you about algorithm. This is a lot of things actually already written about algorithm in the topics. You will find algorithms and description of this. Folks, actually being committed by computer, these algorithms will become a program. The difference between algorithm is program, that algorithm use human definitions here, human words to describe things. Computer use just numbers. So for example, the code of make step will be, for example, binary code 1001. And for computer is 1001, but for human it will be just start. You understand, right? So the different situation. Binary code in the computer will corresponding to the words in the algorithms in human perception. So this is actually what I would like to tell you about algorithms today. But I have about 20 minutes to continue, and then I would like to tell you a few words about peripheral computer devices. Peripheral devices of the computer. What is peripheral devices, folks? Basically, when we have the main module of the computer, we call it ALU. ALU, it's arithmetical logical unit. Why arithmetical, folks? Because computer make calculations. Computer is capable to make calculations, arithmetical calculations. Why it's logical? Because logical, you just have seen, I did algorithms, and computer actually can commit this, can run these algorithms, can execute these algorithms, and get the results. By the way, algorithms are also connected with algebra of logic, which actually I will give you a specific session about it. But folks, computer can actually calculate your eligibility for grant. For example, if you can calculate, are you eligible for TAP and Pell grants for your education? So first of all, are you a New York State resident? If yes, are you 21 or older? If yes, have you
21.
been? Okay, so if 21 or older, then are you eligible for TAP grant? Yes, you are. Right? You understand. So folks, computer actually can calculate and doing logical operations. So calculate your eligibility, possibility, and so on. But